水茫茫，20年纵横间谁能相抗？恨与狂，肠道所向，多少手足忠魂埋骨他乡。可惜百死抛家国，任叹息更无语，血泪满眶。
How to lighten the scene load. On the screen you can see the mold assembly machine. The fixed parts, hollow holes already being removed. We load this scene file from C drive, the data folder, not in CMS CAPP data folder, because for the demonstrations how to remove all the holes of the movable parts. Before taking these lectures, I suggest you to download a step file from our websites. The file name is 好神托资料夹. Inside there is a yf07.step. Then open a file folder SAM11 on C drives. Then we started to remove these two holes of the right sides. This top one is cutting cylinders. After the steps in SAM, then we can open SolidWorks and use open old file from SAM 11. You can see the step here. Simply pick this step and open it. A few minutes later, the whole 3D model will appear on the screen. This 3D model, the same with Y and Z upside down. We have to use the right hand rule to rotate the whole components about Z axis 90 degrees to let the Z axis point to the sky. Then we have to find the cutting cylinders components and to do some works to remove two holes on top of it. The lighting is very important. Suppose for shipbuildings, we have to show the whole compartment, together with piping, with longitudinal, with brachydal, with fittings, machines, whatever. Those components occupy the space of the compartment. We have to decide which one first, and the rest has to avoid to bump with the main components, etc., especially at the design procedures. The same like this. The only thing we have to appear is the outside of the 3D model. The inside components or something like the holes, you can remove the holes to let the triangle surface as less as possible to lighten the seam loads. Okay, the model is on the screens. Before we doing anything, we have to turn around X 90 degrees to let Z point to up, because this is the right hand rule. The thumb of the right hand has to point to here, so the 4 fingers turning to these directions. That's the reason why we have to turn around X 90 degrees to let Z turn to the up, point to the sky. Okay, how to turn the whole models together? Simply press the cursor left button at here and pull to the right button. You can see a blue square on the screen, and release the finger. You will highlight the picked. Actually, the whole components are picked. Put the cursor on the triangle here and pull it back, pull it down, and pick the rotation. The whole components. Pick it and change to from delta XYZ, and delta X give 9 in front of 0, 90 degrees, and adopt it. You will see the Z direction, these directions, and at the top, point to the top sides of the machine. And okay, that's it. After this, you have to save it. File. Save the file. Save and another recalculate. And the file name YF07.asm assembly file. Save it. Save all. After save, we commencing to pick the left cutting cylinders play, and to let it display lonely, and hidden the rest of components, and then doing some works to remove the holes. Okay, then press the middle wheel to turn the model to the right positions, and to see the component just here. Okay, pick it, and you can see in here, highlight, and press this one. You can see the whole components area, and put a cursor on top of it, and press the right button, and then pick open this component. Okay, press the left button of the mouse, and he will ask us to do some recognitions. We answer no. Okay, now only these components YF07D13s are handled. The assemble wheel just at the rear. You can see at the rear. As you close this file, then the symbol will appear on the screen. Okay, right now we are doing the single component YF07D11 with D13. How to remove these two? Okay, let's see it. By pressing on the surface, you can see the lights highlight. Then press the right button of the mouse and pick orthogonal to this surface. Okay, the surface showing on here with the blue on surface. These moments, use sketch, pick sketch. The sketch 1 opened. Then use straight lights to generate the square. On the corners, you can see the highlights. A brown circle, big circle there. Simply pick by pressing the left button of the mouse, and you can see the rubber band. Go to the second point. As the point highlights, press the left button of the mouse, and still you can see the rubber band. To the third point, the highlight, and press the left button of the mouse. The same to the first point after the point highlighted, and press the left button, and then go back to the first to create a loop. Okay, press the left button of the mouse. Then you can see the surface change the color to gray. Simply press OK, OK, and then use spatial symbol functions and use extend to fill the holes functions. You can see the default is 10 millimeters. Press the middle buttons and move. You will see the rotation of the components. The default is this directions. This thick is 10 millimeters. Then we want to create this size to this depths. Simply pick these points or these points. As these points highlights, press the left button of the mouse. You will see the light brown square changed to this direction, and say OK. Then you will see two holes are removed. Then the color is different from the original one. We have to change the color. Put a cursor on top of the surface and press the right button, and here is outlook. Pick the outlook. To silver ball, we pick the first one, and in here we pick this one, and we have to change to the same colors. The R pixel 0, the green pixel 255, the blue pixel 255. This is what we are defined in previous components, and say OK, and then put the cursor back and press the right buttons and outlook, and pick the second silver ball, and pick this one as well, and change the red pixel to 0, the green pixel to 255, the blue pixel 255 as well, and OK. 2, OK. Then this one is OK. Right now is handling the single components. Don't try to output IGES file in this moment. If in this moment you will get trouble, you can try by yourself. Then how to do? after finished, you have to save the file first, save the state, and then close this file, this single file, close, and go back to the assemble file. Okay, close. Asked if the assemble recalculate the model. Answer no. Okay, go back to the assemble. You can see the cutting cylinder's plate already removed 2 holes. So we already marked this file name. Then we have to hidden all the rest component, only leave this one be seen, and save the only one to IGES file. How to remove the rest be hidden? Simply press the cursor at the top left positions and press the left button of the mouse and keep pressing and pull the cursor to the right down positions, and you can see a light blue square cover the whole model, and release the finger. You can see the highlights of the machine, and in here reflect as well. Put a cursor on top of it simply by press the right button of the mouse and choose this one. Let the components hidden. Okay, you will see nothing at the screen, and the yellow model become white model. So after this, we have to wake up the only components, the left cutting cylinder plate, by typing the marked number. The marked number is YF 07 D13. You can see 2 in here. Let both of them be seen. We have to decide, enlarge these 2. We have to decide which one to save. The left one with the Y values less. The left one. The right one with the Y value bigger. So we have to let this one on the screen and this one hidden. Put a cursor on this one and press the right button of the mouse and pick the hidden. It will disappear. So right now only this one. We have to save the IGS file. Before saving anything, we have to use file and save the file. Save and non-calculation. Save all. So right now YF07 be saved. Only this one be seen, the rest all hidden. In this stage, then use file and save only file and give the type of the file is .iges and give a file name. The file name has to be the same as the cartoon chart. Okay, then save the file first, save another calculation, save all, and then okay, we just doing twice, no problems, and it takes times for the rest works. Okay, let's press again. Okay, a circles means the file still saving. No problem, just wait for the while. Then after the menu on the screen, we use save another file. Okay, this one, save another new file, save and another calculation. You calculate the type, give this one iges.start.igs, and the file name give what? Give to see the cartoon charts. The cartoon charts in this one, this is a cutting place, cutting cylinder plate. The file name should be y23x36. So in here we write down y23s36 and press enter. We are asked, one or more components be hidden. Do you want to unsolve this hidden? The answer is negative. No, we still let the rest be hidden. We only output these single components. Okay, the IGES file created. Then we have to change this IGES file to X file by open polychance. Okay, and use translate import 3D geometry IGS formats, and the file folder is in C drive, and the file folder's name is SAM11, and the IGES file is Y23x36 IGES, and okay, yes, you will see the models on the screen. Then export 3D geometry direct as file. These two not picked. Okay, the file name give Y23s36. The positive normal direction we use A at real. Okay, and then the negative sides of the components. Export 3D geometry. The file type is direct as file, and pick reverse orientation of all polygons and the normals, and pick flip polygons normals to let all the triangles surface the normal directions changed to the negative direction. Okay, and the file name Y23x36 with a B at real. Okay, so after the positive and the negative S file out, then we have to load them back and output a single combination, and use translate, use recessing negative to remove the screen, and translate import 3D geometry, and use import 3D geometry, and the file folders file extension is direct as file, and the file folder is in C drive, and the file folder's name is SAM11. Open the folder, and the positive side first, A in. Okay, yes, you will see Y23x36A in, and the negative import 3D geometry direct as file. The B side, open the file. Okay, in. you will see the negative Y23X36B in. The both positive and the negative in, then we have to save the combined X file by using export 3D geometry direct X file, and these two pick removed. Okay, and the file name give only Y23S36 only .x. Enter. Okay, after this one, before doing anything, we reset scene and save nothing to remove the screen, and use file handling to save from C and send 11 folder and search the Y23S36. Copy this file and to the C drive, the data file folder, and find the space and press the right button of the mouse and stamp on top of it. Duplicate and substitute Y23X36.x file. This one. After this new one, then we can go back to CMS CAPP, reset to stop the PLC operation, and new to clear the screen, and the scene input name of scene, and the input from C data drive file folder. The file CSV file name is YF7 new. Open this file. Okay, the model on the screen. You can see the left coating cylinder driven plate, 2 holes removed, and you can use PLC modes and to see the machines operating. See this one? Okay, working excellent. Then next we want to do a more complicated one. This one is at the left side at the top. The X file name is at u.x with too many holes and with teeth at this side. Then let's see how can we do resets, and let's go back to SolidWorks. Okay, to SolidWorks, this one we close it and file, save the file, save all, save and no calculation. How can we go back to the assembly display on the screen? We can try to pick the cross to close this one. First try. Okay, let's close it. You see, you close the one, you will see the hole at the rear. Then pull the bar down. We have to pick hole by ourselves to show the whole components. Press the cursor here and keep pressing and pull to the right down positions and release the finger. The picked components will highlight. You can see everything already in, and put a cursor on top of it and press the right button and pick the eye. Sure, the components of the assemble. Then you can see the whole components and here, and this changed to yellow geometry square. Okay, let's enlarge the drawing. This one is what we intended to do, and press anywhere and pick here. You can see this one not include the two teeth in here. Okay, we handle this one first. After this one highlights, we put the cursor on top of it and press the right button, and the first one, open this component and asked, do you want to continue the recreation, whatever. Answer is no, negative. Okay, these components op.208 grippers on the screen. In polytrans, not allowed Chinese characters, so we have to remove these characters first. How to do it? The way to do this one is use file. Save another new file. Save another new file. The type keep.prt. The file name here. Remove all the Chinese. Left English only. And write down op208 for later use. And then save it. You will see the file name here changed as well. The Chinese characters removed. Okay, the first step finished. Then let's to handle the teeth. The same. We find a place suppose here. Put the cursor on top of it and press the right button of the mouse and pick orthogonal. Look at this face. You can see this face, and pick sketch and pick straight lines function and put this corner first, as the corner highlights as a orange dot. Pick the left button of the mouse, and you can see the rubber bands to go to the maximum positions, as the point highlights as a dot orange. Push the left button of the mouse and continue to the next points. As the point highlight, push the left button of the mouse. Continue to the fourth points, as the point highlights as a orange square, orange circle, and push the left button of the mouse, and then go back to the first one and press the left button of the mouse. After loop created, you can see highlight as a great square, and say OK. Then use symbol, special symbol functions. Choose elongation and fill the holes functions and pick it, and push the wheel and move the cursor. You can see the model turning aside. The defaults 10 millimeters along the different direction. We have to lay it down to here, up to these points. So we just give the depth to push these points or these points. As the points be highlighted, we push the left button of the mouse. You will see a light yellow squares covered the whole areas defined by the square just defined and the points. Okay, then we say okay. You can see the teeth removed, the hole removed, these positions. Okay, but we still has to handle these parts. These parts is better use this out profile and extend this distance. Okay, let's do the same process. Put a cursor on top of the surface and press the right button of the mouse and pick orthogonal to this surface, and you can see the surface highlighted. And these moments we can use sketch, pick a sketch functions, and the same we can use the straight line point to points to connect all of it. As you push the sketch, here is a sketch tool opened. The fastest way is use this one, this symbol. As you press this symbol, you can see a yellow loop and a yellow arrows, and here says 10 millimeters. What is 10 millimeters? Is from here to here is for 10 millimeters. From here to here is 10 millimeters. But what we need is the original size. How to do it? Just to change 10 millimeters to 0 millimeters. And after that, say OK. You can see this one shrink back to its original profile. Then press OK again. This way, fastest. And the same, use a spatial symbol, use elongation and fill the holes functions, and push the middle wheel and turn to see a sides, and give the depths simply to pick these points or to pick these points. Okay, let's pick these points. Then the yellow envelope to the space where we intended to remove the hole. Okay, this is good. Then we press OK. You can see the holes all removed. Next, we have to change the colors. Press the right button and choose Outlook, and the two silver ball, the first one to handle. And let's pick, how about to pick this one, the dark, this gray. Okay, so this one, okay, and this marked, but we still has to take the teeth, the two teeth in front. Okay, let's save first. Okay, saved. After saved, we have to go back to assemble to find the name of the teeth. Simply cross the O file, negative. Okay, then this teeth and this teeth. Put a cursor on this one and pick this one. This one, write down the file name YF07 CO3 1. Okay, and then pick this one, YF07CO32. Okay, we know this two, and this one 3 components. Then we write them down already. Okay, let's hidden all the machines first. The send, press to highlight it, and press the right button and pick this symbol. Everything height. Then open the picked 3 components. The first one is OP 208. OP 208. Open this one. Okay, let's 3 open, and open this one as well, and enlarge the join. We have to decide these 4 components, which one is what we intend to do. The Y bigger is at the right side, so the left side, this 3. The Z, this direction, so this one is what we want. This 3 we have to remove. The first to remove this one, the second to remove this one, and last one to remove this one. So after this removed, we have to pick another 2 teeth, remove to left the space, and type in YF07CO3. Number 1, this one or this one. Let's highlight to see. Okay, this one. Okay, then still the same YF07CO2, but number 2 definitely this one. You see? So 1, 2, 3 on the screen. Then we can save IGES. How to do it? The first things is we have to save the file first. Save all. Save and no calculation. File is saving. Right now it's not handling anything, so we can save IGES file. The file name is lu.x. Actually, it's IGES file is lu.igs. How to do it? We save it already. Then save another new file. Save and no calculation. The type should be IGES.igs. The file name, the file folder, SEN11. The file name must be LU. Okay, press enter. And the rest not still be hidden, so we give negative. So lu.igs created. Then using polychance, translate, import 3D geometry, IGES file. The file folder from C drive, and the file folder is SEN11. The IGES file name is lu.igs. Open it. Okay, yes. Start Sync Optimizer, start. Yes. Okay, you can see with 2 T's LU without holds at all. Then the positive normal direction by export 3D geometry, direct as file format. These two left name blank. Okay. The file folder. Okay. The file name should be LU with an A at real.x file, and then the native export 3D geometry direct as file. Pick reverse orientation of all polygons and the normals, and pick flip polygon normals to change the triangle normal to the negative direction. Now, okay. The file name LU with a B at real LUB.x, save it. Then the positive negative saved. Then use reset sync negative to clear the screen, and the sync translate import 3D geometry direct as file formats from the file folder from C drive, send 11 and LUA positive in first. Okay, yes, the join the name LUA, and import 3D geometry direct X file, LUB next, open this file. Okay, yes, LUB in. So we have to output a combination single file out to send 11 by using export 3D geometry direct as file formats. These two, let them blank. Okay. The file name use LB only, LU only to create LU.x, enter, and reset sync negative. So LU.x created. Then we have to copy from C drive, send 11, C drive send 11, and LU okay, something happened. Let's do it again. Reset sync, translate, import 3D geometry direct as file, send LUA in. Okay, yes, and import direct as file, LUB next. Yes, and export 3D geometry direct as file, send 11 LU, save it. Okay, then remove the screen, and then from C drive send 11, C drive send 11 to find LU.x. Okay, here it is, LU.x. Press the right button, copy, and go back to C the data and file space. Press the right button of the mouse and put it on. Put it down. Duplicate and substitute lu.x. Yes, the lu being the new component in data file folder. Then go back to CMS CAPP to reload to see if this one become new one. Use new to clear the screen and use scene input name of scene to open YF7 new CSV file. Okay, you can see the new one in without teeth, without hole. Okay, let's use PLC mode and cycle start to see the operation. Okay, it works. Okay, then use this way we can remove all the holes. The previous running 6 seconds for one cycle. After all the holes removed, the cycle time reduced less than 5 seconds, similar to PLC program written by ladder. Okay, this is very important to lighten the scene. We spend some time to explain these two examples, and you can use the same weight to remove the rest holes of the movable components. Okay, end of this lecture.
山北望，勇气转马，长嘶剑气无双。心似黄河水茫茫，20年纵横间，谁能相抗？看云方，长刀所向，多少手足忠魂埋骨大